Okay, online should be Miltos, Bastian, and me from Humboldt University of Berlin. I don't know if our two Chinese group members are online, but I don't think so. So we'll just start without them and see if the presentation will go well.
Okay.
So our topic was the Breitenberg vehicles. We wanted to build something in the 3D environment because we wanted to scale up the behavior of the Breitenberg vehicles, not only in the 2D dimension, but in the 3D dimension as well. And we first thought about using the WebOds program, but then we decided on doing something totally different in the browser via WebGL. After we decided on doing that, we set a goal to let the Breitenberg vehicle interact with a light source, only with a light source, not with obstacles, and implement different behaviors regarding the light source. So we prepared the main project by first using Google Documents, which wasn't really helpful because our Chinese group members couldn't use most of the stuff because there were some restrictions in China concerning Google. So then we decided on using GitHub. I think Bastian or Miltos will say something about GitHub later, why we didn't use it the way we thought we would in the end. To build our 3D online website Breitenberg vehicle demo, we used the programming languages JavaScript, HTML, PHP, and CSS, but also Bastian will say something later about that. And we also used a web framework that already was implemented by Bastian before. Our project was, let's say we set some milestones for the project to check whether we have some results and who's doing what and who's doing it when. So our milestones for the whole project were like this. We first used the WebOds and created some Java controllers for it, because we first decided on using Java for the whole Breitenberg vehicle project. I think it was maybe 3 or 2 days later when we actually had another idea on using a totally different approach to the project by using WebGL and a browser. So the next milestone was setting up GitHub and the communication channels for the group after we encountered some problems with Google. And then we created the website with the 3D environment view and the framework that Bastian already had. Then we actually started implementing and created the feature to control the vehicle in the first-person mode. And after that, we implemented some automated control code for the vehicle. Bastian will later show you a demonstration of the website if you haven't seen it yet. So any of the information I just provided you will be more clear later, I think. The whole 3D environment needed some borders and some map objects like the light source and the actual Breitenberg vehicle. So we also implemented that until today. And that was pretty much everything we wanted to do. And then we also set up some additional milestones which we actually set to complete, but if we didn't complete them, it wouldn't be too bad. But we also did one of them, which was the enhanced lightning implementation. But Miltos and Bastian will say something later about that. Okay, I think now it's Milto's turn for the presentation.
Should I share my screen, or will you change the slides for me?
No, I think it's better if you share your screen.
Yep. Can you see now?
Yes, we can see your slides. Oh, there we go, yeah.
Okay.
Yep.
Okay, now we'll talk about the collaboration. Every team member of the group got his own job assignment, and after that the results were sent to Bastian, who integrated this into the existing code database. So everyone got the code and sent them to Bastian, so he integrated it. Two more things: Git was rarely used, and communication was done mostly by email. And that's why, because we just everyone did their job and sent the code to Bastian, who did the integration then, so Git was never really necessary then. So let's continue with the behaviors that were achieved on our Brightenberg vehicle on this project. First, the only behavior not achieved was the aggressor model, which is accelerating towards light. The other three were implemented, namely the coward, which moves away from the light and then stops. The lover model moves towards the light and then stops. And then the explorer model, which moves towards the light and then speeds away. We also achieved a hybrid behavior, which is a combination between the lover-coward model and the explorer model. First, the Brightenberg vehicle moves towards the light. It then waits 3 seconds, and then finally speeds away for another 5 seconds. Next will be the demonstration of the Brightenberg vehicle, and Bastian will take over from here. So, yeah, wait.
Okay, you all see my screen? Hello?
Yes, I think so.
Okay.
Hello?
You see it?
Yeah, 1 second, I'm putting it on full screen now. There we go. Can everyone see these slides? Yeah, okay, then you can continue.
Okay, as you can see, there's also a link. You can also click now or later. It's a website, always online. You can test it whenever you want. I know, try to do it live. It's always a dangerous idea, but we try it anyway. So what you see is we have this small kind of rocket in the middle, and then in a distance we have this white box which presents the light source, and we have three kind of buttons. One is for the camera mode. There's a statical mode that is always from behind of the element. Then we have the free mode, and two focus buttons for once the rocket, which is on focus now, and the light source, so we can toggle between them. And then we have two checkboxes that can be activated anytime. The first one is for the sensors, which are required for the behavior. And then we have the autopilot, which is inactive now. If we activate the autopilot, the rocket starts to move towards the light source, and then after 3 seconds it starts to rotate away from the light source, speeds away for 5 seconds, and then tries to find the light source again and repeats the behavior. If I toggle the sensors offline now, it will search forever for the light source, and online it should find it again and restart the behavior. Now I can also control the light via WASD QA QE and space button, and this can move the light source as I like. And if I switch back to the rocket, I can see it has found the light source again. If I now move away a bit, the camera, oh, where is it? The rocket tries to find it again, and now comes again to the light source, and so we can play some nice cat and mouse kind of play if you want. I can also switch off the autopilot and control the rocket, and then switch the autopilot online again, and the behavior starts again. So much to the live presentation. I can also give you a link to a prepared video that is also online if you like, but I think you also already recorded this presentation. So this was the live presentation. Now a bit toward the implementation. First about the programming languages we used. HTML and CSS used for the layout of the website. PHP was used for the collection of JavaScript code and sometimes also HTML to lower the amount of communication between client and server. Just some kind of glue function for the PHP. And then the core of the entire project was JavaScript. It controls the 3D environment, the elements, more or less everything. Now I don't want you to show you the code entirely, which is kind of boring. So just some central ideas of what we did. We have one central PHP file that collects everything, where all the JavaScript code, the CSS, HTML, and is all collected together. It's a dynamic website, so there are no reloads or so. It's all done by Ajax in the background. And then we have one central JavaScript collector, which collects all JavaScript files. And altogether, we used a very well-structured and separated folder structure to maintain the code in a better way, and to also make it understandable for all the group members. And yes, as I said, PHP was used more like a glue to minimize the amount of downloads. So now let's come to the summary of our presentation. So what we did did create a 3D web environment for the Breitenberg vehicle, which was more or less successful, and can be expanded every. It's quite easy to extend it for more behaviors, or and also to maintain it. It's also for me, and I think for many others too. It's JavaScript and the way we structured the code makes it extremely easy to maintain, and in many ways much easier than Java or C++, because yes, C++ is not really the easiest language, and also Java while quite easy is not as easy as JavaScript, in my opinion. And yeah, the problems maybe of our project were timely communications, especially with our Chinese members. In the end, all communication was done via email, and for us here in Berlin, we use Skype also. But with talking with the Chinese members was quite difficult because they also didn't look too often in the email accounts, as it seemed, and this was quite troublesome. So this was our presentation. I hope you enjoyed it, and now we can go over to the discussion, if you like.
Okay, thank you very much for a very nice presentation. Okay, so I'll open up for questions from the panel. See, we have Verena as well. Anyone want to start? Okay, I can start off. I thought this was a really cool implementation, and I was wondering. To me, this looks like a nice tool that people can kind of learn a bit about what, or play around with what a Breitenberg vehicle could be. Do you think? Well, first question would be: will you be willing to keep this online so we can link to it and kind of point students to this in future editions of Shanghai lectures? And then the second question is there any way you could have implemented a way to kind of change the connections directly, so kind of change a bit more in a detail the implementation of the Breitenberg controller?
Well, I think the best way to do it would be to send you the code. What
Okay.
you simply need is a PHP server to run it, and that is all. I think there's nothing so difficult about it.
Okay.
And about the code itself, it's quite easy. I think also, I think, yeah, you can change many things. Also, it's easy to extend the behavior. So doing simply just a light lover, which we did in the first place. So the rocket always just leads to the light source, and then nothing happens.
Mm-hmm.
In the end, it needs a bit documentation, I think.
Okay.
But it should be quite easy to understand for everyone who wants to work with it.
Okay, great, thank you. Any other questions?
No, actually. The arrangement of sensors?
What?
The arrangement of sensors, do you have any ideas whether this could be easily modified to use maybe different sensors in addition to the ones you used?
So what we have is we have a direction of every single sensor. We currently the code works with 4 sensors. To extend this would require some minor arrangements, but after that it should be quite easy to change the direction of the sensors, or in the case of different behavior of the sensors, so not just sensing light but object. It's a bit difficult because that's why we just decided to use light as the only sensor target, because object sensing requires ray tracing and all that, so you have to send out rays from the sensor into the void, and then mathematically calculate whether there is some kind of collision or some kind of that, and that makes it quite a bit more difficult and time requiring, and thus we didn't do it, but it can be done, of course.
Okay, thanks.
Okay, any other questions?
No, just actually, Martin and Verena spoiled my questions, so I only have to say.
I'm sorry, Fabio.
No, to comment with it. No, it's a very nice, nice work. So I don't, I didn't get if you are going to make it available on the web, or if you think that we could use in the future in the ShanghAI.
I would like to send you the code. It wouldn't. I don't have some kind of copyrights or so for it. I like to see it anywhere used.
No, we could use a typical Creative Commons, no, let's say share non-commercial. I think, no, so that if people use for education, it's okay. Assuming that education stays a non-commercial activity. But
I think I can talk with Verena,
but
Professor
actually,
and we can do that.
okay, thank you again.
All right, thank you. Let's give another applause.